All right, in this video, we are going to graph some exponential functions. We're also going to talk about f of x equals e to the x as well. That'll be at the end of the video. So at the top here, you can see an exponential function is going to be of the general form a times b to the x, where a and b are real numbers and b is positive but not equal to 1. In parentheses here, I've explained why b needs to be positive but not equal to 1. If b is less than 0, then b to the x would not be a real number for many of the values of x. For example, like if b were -3 and x is 1/2, you'd be trying to take the square root of -3, which is not a real number. Also, b cannot be 1 because the graph would be a horizontal line. Down here, we're going to graph, and in these graphs, we're going to let our a be 1. Okay, so we're just going to look at f of x equals b to the x. An a that is different than 1 is just going to stretch or compress the graph, but we're going to have our a equal to 1 each time. If b is greater than 1, then we're going to see that the function will increase, and we'll go through the point 0, 1. There's also going to be an asymptote at y equals 0, which is the x-axis. And then if b is between 0 and 1, so a fraction with the numerator smaller than the denominator, then our function is going to decrease. It will still go through 0, 1, and there will still be an asymptote at y equals 0. So I'm going to show all of this that I typed up here by just making a t-chart. So we're going to see. We're not going to need to memorize any of this. We'll see in our t-chart. Okay, so the three we're going to graph, we're going to look at f of x equals 2 to the x, f of x equals 3 to the x, and then we're going to see what happens when b is between 0 and 1, so a fraction. So this one is going to increase. It's exponential growth. This one's going to increase, but we're going to see this one is exponential decay. So it's going to actually decrease. Okay, so starting with number 1, I'm going to make a t-chart down here. And on the left side, I'm going to pick some values for x. On the right side here, I'm going to plug those values in and see what I get. Okay, so how about, I'll start with 0. If I raise 2 to the 0 power, it's 1. Anything to the 0 power is 1. So 0, 1 is going to be on our graph. It actually said that up above as well, that 0, 1 is going to be on these graphs. So 0, 1. Maybe I'll plug in 1. And 2 to the first power is 2. Maybe I'll plug in 2. 2 to the second power is 4. Okay, let me start to plot these, and then we're going to plug in some negative values for x. We don't want to just plug in positive values. That's going to help us to see why we have an asymptote along the x-axis. So 2, 4 is here. Okay. Now I'll plug in some negative values, like -1. I'm going to show my work over here. 2 to the negative first power is not a negative number. Okay, we saw this probably one of the very first days of class, that I'll write it up here. A to the negative n power is 1 over a to the nth. So 2 to the negative first is just 1 over 2 to the first, which would just be 1/2. So this is 1/2. I'm going to make a really big t-chart here. 2 to the negative second is 1 over 2 squared, which is 1/4. Okay, and I could keep going. I could do 2 to the negative third. That would be 1 over 2 to the third, which would be 1/8. I could do 2 to the negative fourth. And that would be 1/16. So I'm trying to show you that, go up just a little bit more, 1/16 here. I'm trying to show you why there's an asymptote along the x-axis. I could keep plugging in negative numbers, and they're going to get closer and closer and closer to 0, but it'll never actually be 0. Even if I take 2 to the negative 100th power, it's still going to be 1 over 2 to the 100th. Now it would be approximately 0. Okay, but it still wouldn't be exactly 0. Okay, so that's why we are going to have an asymptote along the x-axis here. Okay, so I'm just going to dash in my asymptote here along the x-axis. So this curve is going to get closer and closer and closer to 0, but not actually ever be 0. All right, so let's plot some of these points. So -1 is 1/2. -2 is 1/4. And you don't have to plot in the other points. I was just trying to show you that these y values are going to get closer and closer and closer to 0, but not actually be 0. So we've got a curve. We can see it does increase. Okay, and we do have an asymptote along the x-axis, so I'm going to draw my curve to approach but not touch or cross that asymptote. And this is really hard to do on a computer. Okay, not bad. All right, so that would be the graph of f of x equals 2 to the x. Okay, so notice that it does match what we said up here. We said that it was going to increase when b was greater than 1. It's going to go to the 0.01. It did that, and that there will be an asymptote at y equals 0. So, okay, now let's look at 3 to the x. We're going to see that this graph is going to look very similar to the one we just made. The only difference is it is going to increase just a little bit faster than our previous graph. So if I plug in 0 for x, 3 to the 0 power is 1. Anything to the 0 power is 1. 3 to the first is 3, and 3 to the second power is 9. I could also plug in a negative number. 3 to the negative first is 1/3. 3 to the negative second is 1/9. Okay, you could just take these answers that you got for 1 and 2 and put them under 1. So here's 0, 1, 1, 3, 2, 9, -1, 1/3. Okay, and then I won't try to plot -2, 1/9. That would be really, really close to the x-axis. Here's my asymptote. And then, like I said, this is really hard to do on a computer. Ah, okay, not too bad. Sorry, I just missed that last point. So imagine this curve went to that point. So notice it does look a lot like 2 to the x. It just increases a little bit faster because of that 3. All right, now let's look at f of x equals 1/2 to the x and see how this is going to be different because our b is less than 1. It's between 0 and 1. It's a fraction. So let's see what this one is going to look like. And I kind of already told you it's going to be exponential decay. So let's see how this is going to end up decreasing. Now, anything to the 0 power is 1. So if I plug in 0 for x, it's still going to be 1. 1/2 to the first power is 1/2. 1/2 to the second power is 1/4. Let me show that. I'll scroll back up here in just a second. I'm just going to show you why 1/2 to the second power is 1/4. If I take 1/2 and I square it, it's the same thing as squaring the numerator and squaring the denominator. 1 squared is 1, 2 squared is 4. We see it's 1/4. You could also, when you're squaring 1/2, you could also take 1/2 times 1/2. Same thing. So 1/2 times 1/2 is 1/4. Now let's plug in some negative numbers and see what happens. So what if I raise 1/2 to the negative first power? Well, that is equivalent to 2 over 1 to the first power. We have, I'll write it over here, we have that a over b to the negative nth power is the same thing as b over a to the nth power. It's really just kind of a variation, I guess, of this law of exponents up here. So it's kind of applying this where you've got a quotient here, a over b. So I can flip it, raise it to the first power. So 1/2 to the negative first power is 2. And 1/2 to the negative second power, that's the same thing as 2 over 1 squared, which is 4. Now let's plot these points and see what happens. So 0, 1, 1, 1/2, 2, 1/4, negative 1, 2, and negative 2, 4. All right, so can you see why this is exponential decay? Why the graph is decreasing? Okay, so it's still a curve. We still have an asymptote along the x-axis. But now our graph is falling from left to right. Okay, so that's how we graph our exponential functions, b to the x. The next thing we're going to look at is shifts. Now we've already seen some shifting in our class so far. So now we're going to shift these graphs that we've already made. So note that these are just shifts of the graphs on the previous page. So we still have a b of 2, a b of 3, and a b of 1/2. But instead of just an x, we have an x minus 3, we add 5. So we have to go back to our shifting rules from, let's see, I think we did that a couple units ago. So, all right, so this one is going to look just like f of x equals 2 to the x, but it's going to go, this means right 3. This is the one that's weird, it's subtraction, but we actually go right. Okay, so this one's right 3, and then this means up 5. Okay, so we're going to take f of x equals 2 to the x from the previous page. So we're going to do that, but we're going to go, so take this, and this is right 3 and up 5. Now we're also going to shift the asymptote. Now our asymptote is a horizontal line. You can't move a horizontal line right 3. Okay, it's a horizontal line, it extends indefinitely in both directions. But you can move it up 5. So we are going to move our asymptote up 5. All right, so I'm going to graph f of x equals 2 to the x that we did on the previous page here. And then I'll show the shifting. So we'll do 2 graphs on the same coordinate plane. So that graph had the point 0, 1, 1, 2, 2, 4, negative 1, 1/2, negative 2, 1/4. But we know that these are going to approach the x-axis, but never actually touch across. So I think these 3 points are enough. So here's my graph of f of x equals 2 to the x. So I'm going to call this f of x. We did this on the previous page. All right, now I'm going to use a different color. How about green? Now I'm going to graph g of x up here. So g of x is going to look just like this, except it's going to be shifted right 3 and up 5. So I'm going to take this point here. I'm going to go right 3, 1, 2, 3, and also up 5. 1, 2, 3, 4, 5. Okay, so I've got this point. Now I'm going to take this point right 3, 1, 2, 3, up 5. 1, 2, 3, 4, 5. Okay, so it's right here. Then I'm going to take this point right 3, 1, 2, 3, up 5. 1, 2, 3, 4, 5. Okay, then I'm going to take the asymptote. I'm also going to shift it. As I mentioned earlier, you cannot move a horizontal line right 3. Okay, it extends indefinitely in both directions. but you can move it up 5. So it's going to go up 5. 1, 2, 3, 4, 5. It's going to be right here now. All right, and then here is the graph of g of x. Okay, so notice it looks just like f of x, except it's right 3 and up 5. Okay, over here, the second one. This one is going to look a lot like 3 to the x, but it's going to be shifted. This is going to be f of x equals 3 to the x, shifted left 1 and down 2. Left 1 because of x plus 1 up here in the exponent, and down 2 because of the minus 2. Okay, now on the previous page, we just did 3 to the x at the point 0, 1, 1, 3, 2, 9. It had an asymptote along the x-axis here. And it looked like this. Notice that I'm not graphing. I could have graphed -1, 1/3, -2, 1/9. I was just, you know, I know that the graph's going to get closer and closer and closer to that x-axis. Okay, so now we're going to take all of these points, left 1, down 2. So left 1, down 2. Left 1, down 2. Left 1, down 2. Okay, I'm also going to move my asymptote. I can only move it down 2, though. I can't move it to the left. Okay, that doesn't make sense. It's a horizontal line. So this is the graph of g of x. Okay, so the green one is g of x, and the orange one is f of x from the previous page. All right, one more. This one is going to look like f of x equals 1/2 to the x, but it's going to be shifted up 3. So we saw this was exponential decay. We had the points 0, 1, -1, 2, and -2, 4. And you could also plot 1, 1/2, 2, 1/4 if you want, but whoa, okay, I'm going to try that again. That does not look good. Hey, that's a little bit better. Okay, so here's my graph of f of x. Okay, so this is f of x. And now I'm going to take every point and move it up 3. I'm also going to move the asymptote up 3. So 1, 2, 3. Wow. Sorry, guys. I'm having a hard time here. Okay, so let's see. So 0, 1 becomes 0, 4. -1, 2 becomes -1, 5. This one I'm going to move up 3. 1, 2, 3. And the asymptote also moves up 3. All right, and this is g of x. All right, so we can see that just as we could shift, let's see, we shifted square root functions, we shifted, trying to think what else we did. Oh, absolute value functions, so we can shift these exponential functions. All right, there's one more thing on this video, and that is how to graph f of x equals e to the x. This is known as the natural exponential function. E is an irrational number that is approximately equal to 2.71828, and we see E in several applications, including interest, carbon dating, and bacteria growth. So there's another video about applications of exponential functions where you're going to revisit this irrational number E. So now we're going to graph e to the x, and then we're also going to shift that. We're going to graph e to the x minus 3 minus 2. Okay, now e to the x actually looks a lot like f of x equals 2 to the x and f of x equals 3 to the x, because e is just a number between 2 and 3. So we're going to see that, we're going to have some decimals here instead of whole numbers when we graph. Although we had some fractions before, but we're not going to have, since e is irrational, we're not going to have any whole numbers at all. But we are going to see that we're not going to have any whole numbers for our y variable, I should say. But we are going to see that it's going to look just like some of the graphs we've already done. Okay, so down here, I'm going to make a t-chart. And maybe I'll plug in 0, maybe 1, maybe 2. E to the 0 is 1. Anything to the 0 power is 1. Now e to the first, well, we can kind of cheat up here. We already know this is what e equals. So e to the first, what we'll say is about 2.72. E squared, you know what, I'm going to pause the video for a second and pull up a graphing calculator. Okay, I know you're not allowed to use graphing calculators, but your scientific calculator would also have an E button. The only reason why I pulled up this graphing calculator is because I do not have a virtual scientific calculator. So just kind of wanted to show you how we're going to do this. So your scientific calculator would look similar to this. It would have a button that has an L and an N on it. Okay, so that's the natural logarithmic function. But we'll talk about that in a little bit, not on this video, but on a different video. But notice that in yellow above that, there's an e to the x. So if I hit second and then I hit that, it's going to raise e to a power. So I want to raise e to the second power. Okay, so that's about 7.39. Okay, so like I said, I know you're not allowed to use a graphing calculator, but your scientific calculator would have that same function there. I just don't have a virtual scientific calculator. I just have my virtual graphing calculator. Okay, let's plot these points. Okay, so here's 0, 1, 1, 2.72. It's about 1, 3 almost, right around there. And then 2, 7.39. 1, 2, 3, 4, 5, 6, 7. You know, a little bit in between the 7 and the 8. Sorry about that. Okay, so about like right there. Okay, so these also, or this graph, notice it also passes through 0, 1. It's also going to have an asymptote along the x-axis. If you plug in -1, you know, you could plug in a negative. Let me show that real quick. So I could also raise e to the negative first power, and it's about 0.37. Okay, so notice that it really looks just like 2 to the x and 3 to the x. Looks like this. Okay, so it does increase a little bit faster than 2 to the x, but not quite as fast as 3 to the x. And we can see that because e is about 2.71828. So it's between 2 and 3, so we would expect it to increase faster than 2 to the x, but not quite as fast as 3 to the x. Okay, then if we want to graph this, it's just a shift of that. It's going to be right 3 and down 2. So we're just going to go right 3 and down 2. It is going to move our asymptote down 2. Our asymptote cannot move right 3 because it's a horizontal line. But our 0, 1 is going to move down, right 3. 1, 2, 3, down 2. So here becomes, this is our 0, 1. Now we had 1, 2.72. So let me move that right 3. 1, 2, 3, down 2. So it's going to be about right here. It's not the easiest to move these points when they're not whole numbers. When the y-coordinate is not a whole number, but we can handle it. And then let's see, we had 2, 7.39. about right here. So right 3, 1, 2, 3, down 2, 1, 2. So this would be our other point. And so this would be the graph of g of x. Not too bad there. All right, so notice that it looks a lot like this, except that it's shifted right 3 and down 2. You could also, if you wanted to, make a new t-chart if you're bothered by, you know, trying to move the 0.1, 2.72, right 3 and down 2. But, you know, as long as you do it and it's, you know, approximately right 3 and down 2, you should be good to go. All right, well, I hope you have a better understanding of graphing exponential functions now.